Imagine this, you grind through an AI hackathon and you build something incredible. Not just another OpenAI wrapper, but your own custom, self-hosted open source LLM. It goes viral, Reddit, X, Hacker News all start to light up. Then, crash. Queues start piling up, frustrated users, and your moment in the spotlight, gone. Unless you deployed on Modal, in which case you're good. Modal is a serverless compute platform that lets you run AI workloads without managing infrastructure, all from Python. In this video, I'm going to walk you through setting up a brand new AI chat API service, deploying it on Modal, and stress testing it at scale. We'll simulate up to 1,500 users all hitting the service at the same time, and I'll show you exactly what happens on Modal's backend to automatically handle the load. Let's dive into it. First, head over to modal.com for the full tutorial. We're going to be using 4 scripts here. The first sets up our vLLM inference engine in an OpenAI-compatible mode. We'll define a Python image and install the key packages. Then we're going to specify our model. In this case, we're using Meta's LLaMA 3.18b instruct model, quantized by Neural Magic. To skip re-downloading the weights every time, we'll use a modal volume to cache them. This storage will persist across different sessions, and bonus, it's free to use. We're assigning one H100 GPU per container. And here's what I love about Modal. All of this, the image configuration, the volumes, the GPU setup, it's all defined right here in our Python code. No separate config files, no YAML, no wrestling with Docker files, just Python. Let's run that with modal deploy vLLM inference.py. Next, let's run client.py. This script will let us interact with our API using the OpenAI Python library, just like you would with any of OpenAI's own models. We'll run it in chat mode and pass this custom system prompt so that we can chat with the model directly from the terminal. That'll activate the server, load the model weights, and kickstart our GPU container. While that spins up, let's head over to the Modal dashboard and take a quick look around. In the Modal dashboard, we can monitor our apps, view logs, manage secrets, handle storage, and access sandboxes. Here you can see that I have one live app running with one live GPU container. Now, if I go back to the chatbot and send a message, let's say hello here, then return to the Modal app, you'll see that that triggers a new call as the chat gets completed. A helpful tab here is the metrics tab. This lets us track things like the number of live containers, active calls, memory usage, and GPU utilization for this function over time. Now our AI chat service is up and running, but that's just one user. What happens when everyone at your hackathon starts hitting it all at once, or when your app goes viral? That's where load testing comes in. We'll use Locust to simulate hundreds of users chatting with our model all in real time. It runs with 2 scripts. Locust.py defines what a virtual user does, like sending a message to our API. In this case, it's asking for fun data ideas a Modal salesperson might suggest. Loadtest.py sets up the test infrastructure and serves the Locust web UI. Let's fire that up and see how our Modal backend scales. This deploys the Locust web UI right on Modal, giving us a URL that we can use to configure and monitor our load test directly from browser. Let's start small with 10 users joining every 3 seconds. Let's check out the charts tab here and walk through some of the key metrics that we're going to be monitoring. First up is total responses per second and failures. We'll also keep an eye on response times, both the average and the 95th percentile, and the number of users hitting the service. Let's head back to the terminal. Here we can see these responses coming through in real time. Over in our Modal dashboard, you'll notice that we have a number of running calls. If we check the metrics tab, there's a nice spike in active requests coming through as that load test starts kicking into action. Let's take it up a notch. We're going to scale to 200 concurrent users all hitting the service at the same time and see how Modal handles it. You can see a big spike in the responses per second here, and if we head back to the Modal dashboard, you'll notice that Modal is automatically spinning up new GPU containers to handle the increased load. Now we're at 200 users. As the new containers kick in, we'll see an increase in overall throughput, while latency should remain relatively stable, just a few minor hiccups, and importantly, 0 failures. Let's take our load test even further. We're going to scale to 1,500 users, all hitting our service at the same time. This is where most setups would start to crumble. Queues would start backing up, response times will start to spike, and errors will start to creep in. But with Modal, that's not the case. We're now at 1,500 concurrent users, and our response rate per second has absolutely taken off. Latency briefly spiked, but then quickly stabilized, and the best part, 0 failures. Back in our dashboard, you'll see a spike in the number of containers being spun up. Each of these represent a new GPU container being cold started to handle the additional load. And remember, all of this scaling is being handled automatically by Modal. And just as important, Modal scales down when the load drops. I ended the test about 15 minutes ago, and as you can see, all the GPU containers have shut down. As traffic winds down, the usage of GPU drops to 0, and that means that you're not paying for any infrastructure that you're not using. And just like that, you have an AI service that is ready to go viral. All the links are below. Head over to modal.com and get started with $30 in free compute credits every month. And if you're a startup, you might qualify for up to $50,000 in free credits. Definitely worth checking out. If you've got questions, drop them below. Thanks, and I'll see you on the next one.